Hello, karibu tena kwenye YouTube channel yangu. Katika somo la leo tutaenda kuangalia the Moivre's theorem. The Moivre's theorem. The Moivre's theorem. The Moivre's theorem is just one of the concepts in complex analysis. Therefore, if I forget, please make sure you have subscribed if you are new, and don't forget to click a bell notification. Kwa basi pindi unapokuwa na upload video mpya utakuwa unapitwa nayo, utakuwa unapata ile notification. Hiyo tu ndio upendo pekee unaweza nionyesha tunapoendelea kujifunza. We support each other. This is Philip No explaining. Welcome again. This is Philip No explaining the Moivre's theorem. Say if Z1 is equals to A1 plus IB1 is equals to R1 cos theta 1 plus I sin theta 1, and Z2 is equals to A2 plus IB2, which is equals to R2 cos theta 2 plus I sin theta 2. Remember R and Z. Remember the relationship that exists between R and Z. Z is equals to R cos theta plus I sin theta. This is in modulus argument form. Modulus argument form, and that's why you are saying, you have said that Z1 is equals to R1 cos theta 1 plus I sin theta 1. Okay, so we continue. I've said that if Z1 is equals to A1 plus IB1 is equals to R1 in brackets cos theta 1 plus I sin theta 1, and Z2 is equals to A2 plus IB2 is equals to R2 in brackets cos theta 2 plus I sin theta 2, then Z1, Z2, the product of Z1 and Z2 is equals to R1 is equals to this times this R1 cos theta 1 plus I sin theta 1 times R2 cos theta 2 plus I sin theta 2, and this is becomes R1 R2 in brackets cos theta 1 times cos theta 2 is cos theta 1 cos theta 2, then cos theta 1 times I sin theta 2 is I sin theta 2 cos theta 1, then plus I sin theta 1 times cos theta 2 is I sin theta 1 cos theta 2, then add plus I sin theta 1 times I sin theta 1 theta 2, we get I squared sin theta 1 sin theta 2, and this is the same as R1 R2 cos theta 1 cos theta 2 minus I sin theta 2 cos theta 1 plus I sin theta 1 cos theta 2. So I square, remember that the square root of -1 is equals to I, meaning I squared is equals to -1. So here we have plus I squared sin theta 1 theta 2, which is the same as minus sin theta 1 sin theta 2. Are we there? After that, now we collect the like terms. Where the real parts together, you put them together, and the imaginary parts together. The imaginary parts are those so I can say those factors in this expression that are having I, so we put them together, and those without I, we put them together. So we have R1 R2 cos theta 1 cos theta 2, then minus this sin theta 1 sin theta 2. Are we there? Sin theta 1 sin theta 2, then minus, we can factorize this so that we put I outside the bracket, then sin theta 2 cos theta 1 plus sin theta 1 cos theta 2. But remember, cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 is equals to cos theta 1 plus theta 2, and sin theta 2 cos theta 1 plus sin theta 1 cos theta 2 is equal to sin theta 1 plus theta 2. Are we there? So Z1 Z2 is equals to R1 R2. Remember, I've said that cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 is equals to cos theta 1 plus theta 2. So here you have cos theta 1 cos theta 2 cos 1 theta 1 cos theta 2 minus here sin theta 1 sin theta 2 sin theta 1 sin theta 2. So the whole of this will be represented by cos theta 1 plus theta 2, and then the whole of this sin theta 2 cos theta 1 plus sin theta 1 cos theta 2 will be represented by sin theta 1 plus theta 2, so that we have our Z1 z1 times z2 is equals to r1 r2 into cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. Are we there? And you can call this equation 1, and then the generalization of this I can just write a generalization of this one leads to z1 z2 is equals to, or it's a generalization, or not this way, this z1 z2 dot zn z1 z2, as it continue, it can be z1 times z2 z3 z times z4, as it continue to zn is equals to r1 r2 dot to rn, can be r1 times r2 times r3 r4, as it continues to rn, into cos theta 1 plus theta 2 plus dot theta n. Also we can have more than other thetas, like not just theta 1 and theta 2. We can have theta 3, theta 4 plus theta 5 plus theta 6, as it continues to theta n plus I sin theta 1 plus theta 2 plus dot theta n, just as I have explained for cos. Are you there? And you can call this equation 2. If can say if z1 is equals to z2, which is equals to dot zn, which is equal to z, then equation 2 becomes z times z dot zn is equals to r times r dot to rn cos theta plus theta plus dot theta n plus I sin theta plus theta plus dot theta n and z raised power n is equals to rn cos n theta plus I sin n theta, and you can call this equation 3. And this is what we call the Moivre's theorem. The Moivre's theorem. The Moivre's theorem. And when r is equals to 1, cos z n will be equal to cos n theta plus I sin and theta. Thank you so much for watching. Up to that point we are done. Till next time, bye bye.